Hey there, I forgot to add the answers for the guided practice, so here they are. For the guided practice, we have number 1 being number 8, number 2, the answer is 12, number 3, the answer is 3, number 4, the answer is 63, number 5, the answer is 30, number 6, 180, and number 7 is 12 movies. So as you look through the notes, just see if you can get the answer that's there. I tried to show as many ways possible as I could. Good luck. Okay guys, I realize we went kind of fast, so let me just review real fast. If you copied these notes, great. I want you to realize that you copied the goals, right? What we have to do, we have to find the GCF and the LCM, with the purpose of being, how are you going to use equivalent rates in the real world, okay? Now, I've said it before, make sure you write a book definition for each one, okay? You can use the one that we learned about today if you'd like, but either way, have a definition that you understand. Greatest common factor, least common multiple. Okay, again, page 7 or in the glossary. You did the got-its already. We did some basic notes, how to get there, how to solve these problems. Okay, you have this. You got to this. And we'll talk about this again tomorrow as well. I asked you to do letter D on your own. I hope you did it, because we're going to review it on Monday, actually. So if you still haven't done it, you have till Monday to get it done. Now, let me be honest with you. The only way to get better at this is to do it. You can't learn just by watching me do it. Okay? You're not going to learn it. All right? And goal 2, LCM. You did all this, I hope. Again, you should be reviewing your notes every day, and I'll start putting that down in the homework. Right? Finding LCM. Finding LCM. And the last thing I asked you to do in the video was to write a summary. What did you learn? What did you understand? How is GCF different or the same as LCM? Okay, you have to write 2 or 3 sentences. All right? This is more for you. If you leave it blank, it's not going to help you. Again, you can use your notes during the quiz. All right? So write something that'll help you remember what you learned up here. Okay? All right, now, what I asked you to do next was to take out your notebook and write down guided practice, right? And that's where I got the GP from. Guided practice, it's the initials of G and P, guided practice, GP, page 10, 1 through 7. And what's going to happen right now, if you have your book out, you should have it out, page 10. Okay, you won't see the number. On my book, it looks a little different than yours, but it's page 10. I'm asking you to do 1, 2, 3, 4, 5, 6, and 7. Okay? Don't worry about 8. That's just not even worth it. Not for now. All right? I'll do 1 and 2. You'll do number 3. I'll do 4 and 5. And you'll do number 6. And number 7, you're going to try on your own. It's a word problem, so it might be a little iffy. Okay? I'll help you set it up. But you'll have to do the final work at the end. Okay? So here we go. Guided practice. Find the GCF of each set of numbers. Okay, number 1. And by the way, do all the work in the notebooks. Okay? Greatest common factor. We're trying to break down these numbers into factors. Okay? You got to know your times tables. You can use your times table chart. And today we talked about factors being almost the same as groups. Right? We're trying to break this down into factors. Okay. I'm going to do it this way real fast. 1. You can always start with 1 for any number. 1 times 8. And then my question is, how many groups of 2 can I make out of 8? Equal groups. Now, because I know my times tables, I know I can make 4. Okay? Now, can I make groups of 3? No. Remember, you don't have to do this, but I'm just showing you the smallest factor will always be 1. The biggest factor will always be the number itself. So I put down 1 and 8. These are connected. 2 and 4. These are connected. In the middle, 3. It doesn't work. Okay, if you don't believe me, again, let me show you the proof on the side. By the way, the side here that I'm using is for you to write down questions or things you notice or things you want to verify with me. Okay? Groups of 3. Does it work? again, we have 8. I have 1, 2, 3. 1, 2, 3. But then a group of 2. It doesn't work. I need equal groups. 4 works, and the numbers between 4 and 8 don't work either. So 5, 6, 7 doesn't work. And you can prove it to yourself over here if you'd like. Okay? I'll just do it just to verify something. Groups of 5. 1, 2, 3, 4, 5. 6, 7, 8. Nope. Can't make groups of 5. At least not equal groups. Okay? So if you look at what I did, I started with 1 and went in order. I didn't skip around. I didn't jump around. I asked myself questions in my head. Can I make groups of 1? Always. I can make one big group of 8. That works. 2 and 4. Oh, that works because I know 2 times 4 gives me 8. Right? So let's go to 32. Same thing. I can always start with 1. Okay. Can I make groups of 2 out of 32? Now, this is one of those situations where you might have to do division. Can I make groups of 2? Let me show this on this side. Because I don't want you to draw 32 dots. It's just, you could do it if you want. But, hold on, I have to do something real fast. I can make groups of 2 if I want, after drawing 32 circles, but that'll just take too long. So here's my thing. Groups of 2. We're going to change it into a division problem. 2 is the divisor, right? I'm making groups of 2. 32 is my dividend. That's what I want. I want 32 at the end. I'm doing a little division here. Okay. I can make 16 groups of 2, right? Or 2 groups of 16, but it works. All right? So you have 2 options when trying to figure out the factors. You can draw out the circles and figure out how many groups of whatever you're looking for can you make, equal groups. Or you can use division. I'll leave that up to you to decide. 3 doesn't work. So, and again, I'm just assuming you have your timetable chart in front of you. Okay. By the way, I'm going to be honest with you here. I'm going to show you how to use a calculator. Okay. Does 3 work? Right? Can I make groups of 3 out of 32? So basically I'm asking, if I have 32, can I make groups of 3? I have 10.666666. It's not a whole number, so it's not going to work. Try to avoid using a calculator. I suggest you use it after if you want to verify. But either way, 3 doesn't work. 4, I can make groups of 4. I can make 8 groups of 4. That works. 5 doesn't work. 6 doesn't work. 7 doesn't work. And I already have 8. Again, let me show you the line so you can see what's going on. Do you have to do what I'm doing right here? We're drawing the line here? No. But I want you to see that there's a connection. 2 times 16, 4 times 8. And that means everything in the middle. 3 doesn't work. 5, 6, 7 doesn't work. 9 through 15 doesn't work. 17 through 31 doesn't work. Okay. So, when you're looking, let me put it this way, we're looking for common factors. Now guys, I'm showing you a lot of work for this because I want you to see exactly what I'm thinking. Okay, common factors. Another way to look at it is common groups. Remember we talked about prime numbers and really what factors are. You're trying to see how many equal groups you can make. Okay. If this helps you, if this confuses you, then again, like I said earlier, do what works for you. All right. Common factors. What numbers appear on both sides? Okay. By the way, you might need a highlighter just to keep it handy. I have a 1, I have a 2 on both sides, I have a 4 on both sides, I have an 8 on both sides. What does that mean? The common factors. Again, I can make groups of 1, groups of 2, groups of 4, groups of 8. Right? 1 group of 8, 8 groups of 1, 4 groups of 2, 2 groups of 4. Those are the common factors, the common groups. So the common groups are 1, 2, 4, and 8. What's the greatest common factor? What's the biggest common factor? the biggest common factor is the biggest number that they have in common. Again, what's the biggest number out of these four numbers? 8. And the answer is 8. Again, when we're looking for GCF, we're taking a number apart. We're asking ourselves, what kind of equal groups can we make out of these numbers? What are the factors of these numbers? Okay? Greatest common factor. You're taking a number apart. Kind of like division, and you can see where the division comes in. And actually, you can see the division here as well. We're breaking something up into groups, which is what division is. Okay? So keep that in mind. Now, I'm going to do number 2. And I'm going to go a little faster on this because I think you can do this. Actually, I know you can do this. You just got to do the work. All right, now here's the deal. Holy moly. When numbers are like this, when they're really big, oh boy, this is going to be difficult. This will not work. You can still do it, but it's more work. This is where you start using prime factorization. So let me write this on a note on the side. When the numbers are bigger, use prime factorization. Okay, and I'll show you what prime factorization is. It's basically, like we saw in the video, all these numbers, any number you have, any whole number is a product of prime numbers. And you already know what prime numbers are. They're numbers that only give you two kinds of groups. Right? A group of 1 and itself. So let's see. 24. What? If you know your times tables, again, I keep saying it, but it's true. If you know your times tables, it becomes really easy. All right, 24. I see that it ends in a 4. That makes it an even number. If it's an even number, I can make groups of 2. How many groups of 2 can I make out of 24? I can make 12 groups. Circle it. Okay. That way you know it's prime. 12. Again, I see it ends in a 2. It's an even number. I can make groups of 2. How many? I can make groups of 6. Sorry, 6 groups of 2. Excuse me for that. And just go down the line. I can make groups of, well, I can make 3 groups of 2 out of 6, right? Kind of skipped a little bit. Now look at it. These are all prime numbers. 2, 2, 2, 3. All right, 60. It ends in 0. That means I can use a 10. I can make groups of 10, or I can make groups of 5. Let me just do 5. 5 is prime. How many groups of 5 can I make out of 60? 12, because 5 times 12 gives me 60. All right, 12. I see that it ends in a 2. That makes it an even number. I can make groups of 2. How many groups of 2 can I make out of 12? 6. And this should look very familiar because we just did it. All right. It's an even number. I can make groups of 2. How many groups of 2 can I make out of 6? 3. Now see how I keep saying groups of, groups of? You can always draw little pictures if you want, if that helps. You know? Mira, let me just show you real fast. 60, right? I said I can make groups of 5. Well, then just do this. Instead of dots, just do numbers. 5, 10, 15, 20, 25, 30, 35, 40. I apologize for the sloppiness. 40, 45. Ay, ay, ay. 45, 50, 55, 60. That should be 12 fives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, there we go. 12, right? 5 times 12, right? 12 groups of 5, 60. But now I have 12. Same thing. I said I can make groups of 2 out of 12 because it's an even number. Well, how many groups of 2 do I need to make 12? 2, 2, 2, 2, 2, 2. I can make 6 groups of 2 out of 12. Okay, now 6. I have so many ideas going through my head right now. I have 6. How many groups of 2 can I make out of 6? 2. That's 4. That's 6. I can make 3. And that's how this works too. So if you don't know your times tables, you can always add up the groups that you're making until you get the number that you want, and just count out how many you added. Okay? Anyways, so these are the common factors, right? 24 is 2 times 2 times 2 times 3. Now, just for the sake of argument, you can see where I'm going with this. If you have colored pencils, you might want to do this too. It's up to you. Okay. 2, 2, 2, 2. Oops. 2, 2, 3, 3. Okay. I don't want to make it too dark, but you get the idea. All right, 60. Is the same as 5, 5, 2, whoop, different color. You don't have to do this. I just want you to see where I'm coming with it. 2, 2, 2, 3. All right. Oof. Now, since we're looking for common factors, we look for partners. If there's a 2 here, I look for 1 here. Great. And don't worry, if this is confusing you, I'm going to show you another way on top of this. Okay, find another partner. 2, 2 times 2. 2, I don't have a partner here to share, so no. 3, yes. All right. I multiply all that out. GCF equals whatever this multiplies. 2 times 2 is 4. 4 times 3 is 12. Guys, don't get scared, okay? The more you do this, the easier it gets. Okay, anyways. Hi. Now, this might have confused you a little bit. So, let me rewrite it just a little differently. See if it makes more sense to you. Okay? Now, I'm trying to decide where I have more space, here or here. Well, if I mess up, I mess up. Okay. I'm going to write down all the different factors, starting with the smallest one. 2, cross that out, times 2, times 2, times 3. I think I chose poorly, but we'll find out. Okay, now here, start with the 5. Again, I'm going to write with the 60, I'm going to choose the smallest factor. 2 times 2. Okay, I notice there's no partner here. There's no partner here, so I'm going to leave it blank like this. Right? Times 3. But now I notice I also have a 5. That's going to be by itself. Now see, I chose poorly. What I should have done is probably written it over here. So, like I said, mistakes happen. You saw me considering. This is going to happen to you too. If you make mistakes in your notes, you can always erase it and write it somewhere else that makes more sense. Now I'm going to write it on this side instead and see if that works for me better. Okay. Did you see what I did? I don't know if you really saw what I did here. What I tried to do was find partners. 2 times 2 times... The first one was easy. And then when I started writing the next one, I started, okay, match up if I could. 2 with 2. 2 with 2, right? 2 with 2. 2 with 2. Don't worry, it'll make more sense the more you do this. 60 only has 2 2s. Right? And 24 has 3 2s as factors. 24 has 3 as a factor, but 60 doesn't, so I left a little space for 60. Right? 5, 60 has 5 as a factor, 24 doesn't, so I left a little space there. So now what's going to happen, you should be able to see this a little better Oh, excuse me, there is a match. There is a match, right? 3, 3, 3, 3. All right, I'm going to erase this over here so if you look back at your notes, you're like, why did I do it twice? Like I said, people, as Mr. Bob Ross would say, there are no things as mistakes, just happy little accidents. All right. So what matches up? Look. 2 with 2. 2 with 2. 3 with 3. Why do I do that? Because we're looking for the common things. Looking for numbers that they share. Okay? So, and then I just multiply it out. 2 times 2 times 3. And we already know it's 12. All right. Again, don't forget to fold those pages. It helps. Okay, number 3, I'm going to let you decide how you want to do it. 3 is, now you have 3 factors. We're trying to find the greatest common factor or the greatest number of equal groups. What's the biggest size equal group I can make out of all those numbers? And I got to write this on the side. This is just another way to look at it. What is the biggest size equal group I can make? And you really got to know your times tables, people. I hope you can start to see that. Oh, you know what? That's just... You're going to see me make lots of mistakes, people. I'm almost 50. I don't know if that makes sense to you, but the older you get, things just start to go wrong. All right. So what's the biggest size group I can make? As you saw in the other examples, for number 1, the biggest group I can make is groups of 8. Or I can make 8 groups. You can look at it either way. Groups of 8 or 8 groups. For 24 and 60, the biggest size group I can make is 12. Either 12, groups of 12, or 12 groups. All right? So you can do this, making a list of factors like this, or you can use prime factorization like this. Okay? Try it. If you make a mistake, that's okay. All right. After you're done, you're going to get started with number 4, and I'll do number 4. But this time we're finding the LCM, the least common multiple. Now here's the thing about LCM, how it's different from GCF. You have 2 numbers, 7 and 9. We're looking for the LCM of 7 and 9. We already have the group size. Either we're making groups of 7. Oops, too strong for the paper. Or 7 groups. And the same with 9. Either we're making groups of 9, or 9 groups. Right? Either one. So with LCM, we already have our groups, our group size, or the amount of groups. With greatest common factor, we're trying to figure it out. What's the biggest group we can make, or how many groups can we make, right? So if we're making groups of 7, it's like saying, let's go with the groups. We're making groups of 7, groups of 9. How many groups of 7 do I need to match up with the groups of 9? Okay? How many groups of 7 do I need to match up with groups of 9? All right? So, a couple things you can do. Now, this might be the easiest thing to do, but it's also, when the numbers are huge, it gets hard. But for right now, the numbers are small, we can do it this way. Make a list of multiples. And we already talked about multiples. You saw the video I showed you, or asked you to watch. You're just going to multiply. Do 5 at a time. Do 5 at a time. Okay, multiples. 7, right? If I have one group of 7, then I just have 7. That's just times 1. If I have two groups of 7, that's 14. Now I'm going to put it a little closer together because I might run out of space. And you'll see why I say that in just a moment. 14. 3 groups, 21. 4 groups of 7, 28. 5 groups of 7, 35. Right? 7 plus 7 plus 7 plus 7 plus 7. 5 groups of 7, 35. 1 group of 9, 9. 2 groups of 9, 18. 3 groups of 9, 27. 4 groups of 9, 36. 5 groups of 9, 45. Okay, still nothing. I'm going to do 5 more. Times 6, times 7, times 8, times 9. Oops. Hope this works out. 7 times 6, 6 groups of 7, 42. 7 groups of 7, 49. 8 groups of 7, 56. 9 groups of 7, 63. Now, 6 groups of 9, 54. 7 groups of 9, 63. Whoop! Stop. Stop. The LCM, the least common multiple, the smallest multiple that they both have in common, is 63. So what does this mean? I have to buy 63, right? I have to buy 9 groups of 7. 9 groups of 7, right? 9 groups of 7 or 7 groups of 9, depending on how you look at it. I have to buy 9 groups of 7 to get 63 hot dogs, I guess. Actually, since I bring that up, you know how hot dogs, you can buy the hot dog buns and the hot dog franks they never match. One's always bigger than the other. So, if these were the franks, I'd have to buy 9 packages of the hot dogs to get 63. And then for the buns, I'd have to buy 7 groups of 9 to get 63 hot dogs. So the smallest amount of hot dogs I can have without overdoing it would be 63. Okay? Again, these are just groups. Groups of 7. 1 group of 7. 2 groups of 7. I need 9 groups of 7 to get 63. I need 7 groups of 9 to get 63. Okay? That's doing it this way. I'm going to show you the other way. Prime factorization. All right, prime factorization number 5. When the numbers are bigger, same thing. Just ask yourself the questions that I've been asking earlier. Groups of, start with, again, prime factorization. Groups of blank. Okay. Can I make groups of 2 out of 6? Yes. I can make 3 groups of 2, and 2 is prime. Hey, and guess what? 3 is prime as well. Yay. All right, 15. Now, here's the thing. Why don't I ever start with 1? Because I think someone might be asking, why can't I start with 1? Well, if I do that, I'll just be doing this forever. 1 times 15, 1 times 15, 1 times 15. You don't want to do that. That's why we never start with 1. You have to assume, again, 1 is always a factor. You can always make a group of 1 out of any whole number. But let's go with this. Can we make groups of 2 out of 15? Can we make even groups of 2 out of 15? When I say even, let me put it this way. Can I make equal groups of 2 out of 15? Again, if you want to see, if you can always count up. 2, 4, 6, 8, 10, 12, 14, and then 1. 2 is not going to work, so 2 is a no-no. No on 2, no. Can I make groups of 3? Can I make groups of 3? Yes. How many? You can make 5 groups of 3, because 5 times 3 is 15, right? And guess what? Oh, look at that. 5 is prime. All right. Here's the deal. This is where we're going to play with it a little bit. All right. For 6, we have 2 times 3. Right? For 15, do we have a 2? Let's look. No, we don't. Do we have a 3? Yes, we have 1. And then we have a 5. And we don't have a 5 up here. Now, here's the situation. We're looking for the least common multiple, right? We're making groups of 6. We're making groups of 15. How many 6s do I need to match groups of 15? The only way that's going to happen is if you buy, or if you get multiple copies of 15, multiple copies of 6, of whatever you're talking about. Again, 6 books, 15 book covers. All right? So how many boxes of book covers do you need to buy to evenly match books? Okay? Now, we're not sharing anything. We want it all. So here's the deal. We're going to multiply everything, but only with, here, watch what I'm doing. 2, 3, 5. Now, if we were looking for just greatest common factor, we want to know what they share, it would be 3. This would be the GCF. GCF is 3. What does that mean? The biggest groups we can make, the biggest groups we can make out of 6, biggest group we can make out of 15 would be 3. 2 groups of 3, 5 groups of 3. Or 3 groups. But that's not what we're talking about. We're talking about multiples. We're buying more. So I'm going to write down all the different factors. Right? 2, 3, 5. I'm going to multiply this out. 2 times 3 is 6. You know, I'm going to highlight that with a pencil. With a pen. Because I know it's kind of hard to see when I highlight it. Okay. 2 times 3 is 6. Times 5 is 30. So, in the example I gave earlier, now this is LCM. Okay? In the example I gave earlier with books, I would have to buy 30 books and 30 book covers minimum to have an equal amount of book covers so I can cover the books. Right? But that would mean I'd have to buy 5 boxes of books, right? 5 boxes of books. Or 6 boxes, or sorry, well, excuse me. Did that make sense? Let me repeat that. If boxes come in books of 6, and I have to buy 30 books, that means I'd have to buy 5 boxes. So that part I said yes, correctly. But here, book covers come in packs of 15. I need 30. That would mean I need to buy 2. Right? 2 boxes. Now how does that work? It just does, right? 2 times 15 is 30. Anyways, I hope that makes sense. I know you're looking at me like, what? But I don't see a 2 here. No, you're not. You're not going to. This is the LCM. This part I hope you get. Now, what I did here was explaining what this means. So let me say it one more time because I want to make sure you're very certain you understand what. Here, I'm going to just add books. Book covers. I want to make sure you understand how this works. Books come in books of 6. Book covers come in packs of 15. Minimum, I need 30 books and 30 book covers, right? Because I don't want to buy more than I have to. So I need 30 books, 30 book covers. If books come in packs of 6, then I need 6 boxes. So I can get, I need 5 boxes so I can get 30 books. If book covers come in packs of 15, I need 2 boxes or packs of book covers to get 30. Okay? All right. I'll let it go at that. Now you can do number 6. Same thing, LCM. You have 9, 12, and 15. You decide. You can either do prime factorization, right? And just ask yourself the questions, can I make groups of, or you can do listing of the multiples, which is what we did here. Do 5 at a time and see what happens. Whatever works for you. If you want to do both just to practice, you can. Oh, by the way, if you notice, I started with the smallest number first. Yes? That's just a good idea, but you do it your way, whatever works for you. All right, number 7. I did say I would start it up. 7 is a word problem. You have to decide, are we finding GCF or LCM? So let me read it to you first. I know, the paper tore. And yes, the answer is there, but that's not the point. The point is, do you know how to get the answer? And yes, the answer is there too. Like, oh, teacher is being foolish. Again, guys, you can copy the answers all you want, but if you don't understand how to get the answer on the quiz, it's not going to help you. All right, so the movie house gives away $5 coupon for every 4 movies purchased. They give away a bag of popcorn for every 3 movies purchased. How many movies would you have to purchase in all before receiving both a $5 coupon and a bag of popcorn at the same purchase? Oof. All right. So let's talk this out. You got to reason this out. Okay? Again, this is a word problem. Think it through, make drawings, whatever will help you make sense of the math. Okay. A movie house, I'm assuming it's a theater, a $5 coupon for every 4 movies purchased. Okay. You know what? I was going to try and draw like a movie reel, but I really don't know how to draw that. So I'm just going to write the words, okay? 4 movies gives you a $5 coupon. Okay. A bag of popcorn, 3 movies, gives you a... Now this I can hopefully draw. And then you have popcorn. Bag of popcorn. Yay. Okay. And then what else? All right. So it's not a movie theater. Now that I look at it, it's a movie store, I guess, where you can buy movies. All right. Actually, that's funny. That's how old this book is. When this book was made, there was still a place where you can go to rent videos and movies, and now everything's online. But the idea is the same. You can pretend it's Target. If you go to Target and you buy 4 movies, you get a $5 coupon. If you go to Target and you buy 3 movies, you get a bag of popcorn. So the question then is asking, how many movies do I have to buy minimum to get both? Now you could say, well, if I buy 100 movies, I'm going to get both. But why would you want to spend the extra money? So let me ask you something. This is one of those things where you have to ask yourself, are you going to use GCF or LCM? Are we breaking these movies into groups? Are we breaking these numbers apart into something where we don't know the groups? Right? Because that would be GCF. 4 and 3. What are the biggest equal groups I can make out of 4 biggest equal groups I can get out of 3? What's the common factor for both these movies? Am I taking this apart? Or do I already know the size of the groups? Right? If I already know the size of the groups, then I'm buying, and am I getting more of it? Okay? Now, from the sound of the word problem, it looks like I have to buy more movies. Okay? So let me help you here. LCM, GCF, LCM. I'm going to write one word in a question. More? Right? Or GCF, where am I breaking it up? Okay. So am I breaking it up or am I making more? Okay. So it looks like I have to buy more movies. For every group of 4 movies, I get a $5 coupon. For every group of 3 movies, I get a bag of popcorn. So it sounds like LCM. Now here's the deal. The numbers are small. I'm going to decide to use the multiples. The multiple method, where I just multiply it out. Okay? Now, why am I raising to 4? I like using the smaller number first. Obviously, 3 is smaller than 4. Now, I know I said I wasn't going to do this, but you know what's your first word problem? I'm going to guide you through it. Okay? Just to remind you, LCM, if you already know the size of the groups and you want more, then that's why we chose this, or at least why I chose LCM. It looks like we're already buying groups of 4 movies, groups of 3 movies, and we're just getting more of it. Now, if I was breaking it up, then I would use GCF. Okay, you got to read it carefully. You got to maybe draw something that's going on, and then ask yourself that question. Am I breaking something up, or am I where I have to find the size of the groups, or the quantity of groups, or am I making, or do I already know the size of the groups, or how many groups I want, and then I'm getting more of it? But anyways, let's go. I did say start with the smallest number and go with the first 5 multiples. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. I did the first 5. Again, it's just multiples. You're multiplying, multiplying. Okay, 4. 1 group of 4, 2 groups of 4 is 8, plus 4 is 12. Oh, stop. Okay, now what does this mean? This means I have to buy 12 movies, right? 12 movies to get... Now here's the thing with word problems. I might have said this already, maybe not. Always write complete sentences for word problems, okay? 12 movies to get both. Now, if I really want to be specific, I can write more. I need to buy 12 movies to get both the popcorn and the coupon. Okay? All right. So basically, I did almost all the homework for you. Okay? Yes? All right. You just have to do number 6. And I believe I said number 4. I could be wrong. Number 3. All right. Hope that helped.